Good morning students, chemistry with DNA. I am Noman Ahmed and today we are going to start the previous topic of lecture number 1. Let's discuss lecture number 2 of physical chemistry. Physical chemistry. We just started physical chemistry, and in the previous lecture, in lecture number 1, we just discussed rate of reaction. Rate of reaction. Rate of reaction was nothing, just rate of reaction was just change in concentration. Rate of reaction, change in concentration, change in concentration divided by change in time, change in time. And we just discussed rate, which is rate of reaction we just divided into two categories. One is average, one is instantaneous. Instantaneous and average rate. So we just concluded from the previous lecture that rate might be positive or negative. Yeah, we can say change in concentration. So if it rate of disappearance, suppose if we have a reactant A into B, A into P, this is reactant, this is product. So change in concentration of any substance with change in time. So that was the formula we derived. So this delta is a very big amount. So we just changed this in our previous lecture. We said that D, which is negative change in concentration of reactant or product per unit time. So this is also D. So it means that it can be positive, it can be negative. For reactant it is negative, and for product it is a positive, because rate of disappearance of reactant it is a negative, and rate of formation of our product it is a positive. So that was the formula we discussed in very detail. Today we are going to take one important, and also if we just take out the previous lecture, we just have a quick recap in the previous lecture. Suppose there was a reaction on x-axis and y-axis. Suppose the concentration of product, change in concentration, we can say a product, and versus time. So that was suppose we see that after some time amount of product increases. So we can take one conclusion from this reaction. Okay, the amount of product increases, so that's why it will be taken the positive, and amount of reactant it decreases in this term, so that's why we will use a negative sign. Today it will be explained in a very detail later on, but let's have a very good example, that is ammonia. N2 plus H2 goes to form ammonia. In this reaction, let's balance this reaction. This is also in gaseous state, this is also in gaseous state, this is also in gaseous state. So hydrogen is 3 on the product side. So number of hydrogen will be multiplied with 3, it will become 6. So how to make it 6? Just multiply it with 2. Suppose this is a type of reaction, and now suppose we have amount of substance disappeared in this reaction, that is X, and this is suppose Y, and this is product, suppose Z. So if just we want to compare, suppose if you want to compare ammonia with hydrogen. Now see here, nitrogen is 1 and hydrogen is 3. Mean at the same time when nitrogen disappears, appears in this reaction, hydrogen disappears 3 times. Mean here if I have nitrogen on the right hand side and hydrogen on the left hand side, here 3 molecules will be disappeared, and here nitrogen 1 molecule will be disappeared. So the ratio is 1 and 3. Suppose if we just want to compare this and this, so we can say that Y is equal to, this Y is equal to this 3x. Why 3x? because at the same time y, and if you compare x and y has 3 coefficient number, and that is nitrogen has 1, that is suppose 1. So the rate of disappearance of hydrogen is 3 times greater than rate of disappearance of nitrogen. So this is, now if we just compare nitrogen and ammonia, if we just compare nitrogen and ammonia, see, we just comparing Z and X. Suppose Z, now Z is 2, hydrogen is 1. So we can say that Z is equal to 2x. This is, and the rate of formation of Z is equal to 2 times of the rate of disappearance of X. And if you compare Y and Z, suppose if you compare Y and Z, so this is a quite interesting. Suppose you consider 3. Suppose this is 1 and this is 2. It means number of hydrogen disappear is equal to number of ammonia formed. So suppose this is Z is equal to, we are going to compare Y. So here Z is 3 and Y is 2. So this is a quite interesting figures we just drawn out from this reaction. You should know these are kind of things. So let's have a little bit more information about this reaction. Now see, suppose this is a kind of reaction, we can say rate. The rate of disappearance is like we can say, if we change it in a if we explain it in a better way, अगर इसको हम ऐसे लिखें, suppose delta change of concentration of N2 change in time. Of course, this is disappearance, so it will be negative is equal to change of this is 1/3, so we will put 1/3 negative delta H2 divided by change in time is equal to negative means that both will be disappeared. Now see, again if this is positive means rate of formation of ammonia, it increases with the passage of time. So the positive sign indicate that it is a rate of formation of ammonia. And change in concentration of NH3, now this is 1/2 times. Number of ammonia increases, so that's a change in concentration will be like the same. So this is a quite interesting picture we have seen in this reaction. Suppose we place in place of N2 H2, we just place hydrogen, so X, Y and Z. This reaction will be 1/x minus x. Suppose we need not to write minus x is equal to, this is -1/3, y is there, and plus 1/2, z is there. So if you compare these two, like suppose if you just want to compare this and this, so this will be that y will be equal to 3x, y is equal to 3x, this is our answer. And suppose if you want to compare suppose y and z, so just compare it, so that will be 3z is equal to 2y will be formed. And if you compare z and x, if you compare z and x, this and this is compared, so this will be like the same, z is equal to 2x will be formed. So this is a kind of important reactant with a reaction in which we just see whether the rate of disappearance is equal to rate of appearance. So here in this reaction, this is the most important. You have to keep these things in your mind. Okay, suppose these things are completely disappeared. When it disappears, we just put minus sign, and whenever this is formed, so we will put a plus sign with it. So these are a sign of importance. These are most important sign. If somebody asks one, what are the units of rate of reaction? Rate of reaction. What are the units? So this is very important. What is rate? We just discussed rate means change in concentration, change in time. So change in concentration means concentration of product, and change in time means this is like the same. Now see, change in time means k moles per dm cube, concentration means mole per dm cube, and change in time second. So mole per dm cube is called molarity, and second this will be formed mole per second is the unit of rate of reaction. So for today's lecture we just discussed rate of reaction, what is rate of reaction, change in concentration, change in time, and what is average rate, what is instantaneous rate, and this example is very important in examination point of view. Any question you can ask in comment section. Take a very good care of yourself. We will be having a next lecture in complete lecture about lecture number 2. So we will be discussing this. Take a very good care of yourself. Assalamu alaikum.